Hello students, welcome to Educate. In previous lecture, we have studied about capacitance of a parallel plate capacitor, in which we derived the relation, if you remember, that C equal to epsilon naught A upon D. And if the plates between two parallel plates capacitors is filled with, say, dielectric constant K, in that case we have found C dash equal to epsilon naught A divided by D minus T plus T upon K. And in a special case, when this dielectric occupies the entire space, in that case T equal to D, and after that we got epsilon naught A upon K divided by D. I think you remember it. Here you can also write it as C0 times K, means capacitance increases K times. So this all concept you have studied in previous lecture. Then also you studied that if there are capacitors and they are connected in series, then equivalent capacitance, suppose we want to write, then we can write 1 upon C series. This is just opposite to resistances in parallel. If you remember, if three resistors are in parallel, in that case we use 1 upon Rp equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. So here in case of capacitance it is just opposite. So 1 upon C1 plus 1 upon C2 plus 1 upon C3. And if capacitances are in parallel, in that case it is similar to resistances in series. Here R1 and R2 are two resistances, in that case R series equal to R1 plus R2, and here you will write C parallel is equal to C1 plus C2. So the two cases are just opposite, so you can remember the way you like. So these are some basic points that we studied in previous lecture. Now we are going to see one numerical based on this concept. Here question says a network of 4 10 microfarad capacitors is connected to 500 volt supply. This is 500 volt supply, and here these are 4 capacitances. Now determine the equivalent capacitance of the network, and then the charge on each capacitor. Note that the charge on a capacitor is the charge on the plates with a higher potential, equal and opposite to the charge on plate with a lower potential, that you know. So here first of all we will see what is the situation. So situation is simple. Here if you start from here, these 3 capacitances are in a series. So first of all we write this C1, C2, C3. These 3 are in parallel with C4, right? So first of all we have to evaluate the equivalent capacitance of these 3. Since they are in series, so we have to apply 1 upon C series, 1 upon C1 plus 1 upon C2 plus 1 upon C3. We can put the values C1, C2, C3 all are 10 microfarad. So we will get this C series equivalent to 10 by 3 microfarad. That is simple, that you can easily do. Now what you observe, this value is in parallel with C4, and value of C4 is given in our question, all capacitance is in network 4 is 10, so all are equal, so 10. So just find C equivalent will be 10 by 3 plus 10, so this will give 40 by 3 or 13.3 microfarad. So this is first part in which you have to find out equivalent capacitance. Now consider second part in which you have to find out the charge. So here if you see, in a series charges will be same, here, here. So in here charges will be same, here charge may be different. So first of all, let's find out what is charge. So charge on, we can write it that Q equal to CV. So either we can draw diagram like this. Suppose this is C4, as I told you, here this is. So if you want to find out total charge, so you can apply Q equal to CV C dash V, Q equal to C dash V. So total charge you will get, you have evaluated the total capacitance as 40 by 3 and 40 by 3 microfarad 10 power minus 6, and then voltage applied is 500 volt. So this is total charge. Now this total charge you can distribute. Here charge will be same. Suppose this is here Q, so here Q, here Q. This plate will be positive, this will be negative, positive, negative, like that. So that is another thing. So magnitude of total charge, keep in mind, if this is Q, so here just write Q1, 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 and let's write it Q2. Right. So Q1 plus Q2 must be equal to this charge. Now for this capacitance, if voltage is here as 500 volt, so this entire voltage is for this. So for this you can apply voltage Q equal to C, suppose C4 into V. So charge on this, here it is Q2, so you can find. So C4 means 10 microfarad, 10 into 10 power minus 6 times voltage 500. So you can evaluate it, it will become how much? 5 into 10 to the power minus 3 coulomb. So Q2 will be 5 into 10 to the power minus 3 coulomb. And remaining charge will be here. So either you consider this C1 or C2 or C3. So you can find what is Q1. So Q1 will be Q minus Q2. And Q2 is this and Q1 is, Q is this. So you can easily simplify, and it will be 1.7 into 10 power minus 3 coulomb. 1.7 into 10 power minus 3 coulomb. So that is our answer. Now let's see next thing. Next point is energy stored in a capacitor. This is an important derivation. So energy stored in a capacitor can be found by using the method of integration. Let's see how. Initially, suppose some charge is given to these plates. Suppose this plate has charge Q dash, so this will have minus Q dash. So there will be a potential difference, say it is V dash. Now separation between the plates can be taken as D, and the area of each plate is say A. right? Up to here, there is no problem. Now, suppose here first let's capacitance of this parallel plate capacitor C. So you know Q equal to CV. Here, if we want to find out what voltage is there, so voltage V will be here, charge is Q dash upon C. Up to here, I think thing is clear. Initially, the plates are given charge. The first plate is given positive charge plus Q. So thereby negative charge minus Q dash here plus Q dash. So negative charge minus Q dash will be induced on the another plate. So due to that, potential will be from here Q equal to Cv, we will get potential. So V equal to Q dash upon C. Up to here, there is no problem. Now, what we want to do? We want to give further charge dq. And since Q dash is of same nature, positive and this is positive, so some work is to be done when further charge is given. And that work done is stored in form of potential energy. So let's find out small work done when dq charge is given. So dw is equal to, if you remember from the definition of V is W upon Q. So here dW will be equal to V into dq. Whatever charge we are given, dq small q or capital Q, that depends on you. If you are giving capital Q, so it will be dq. So dW equal to V times dq. Up to here, I think there is no problem. Now do one thing. Here V equal to Q dash upon C. So just write here Q dash upon C times dq. This is dW. Now suppose initially there was no charge and till end we want to give, means final charge we want to introduce, that is Q. So we can get total work done in that case by putting the limits of charge from 0 to Q and work. So W will be equal to integration Q dash upon C dq within limits 0 to Q. So how will you proceed? Now W will be equal to 0 to Q dash upon C dq. If you remember, integration x power n dx is x power n plus 1 upon n plus 1, provided n does not equal to minus 1. So same thing we can apply here. W we can write it as energy. So this will become Q dash square divided by 2C, limits 0 to Q. Here 2C is constant, you can keep it outside. So potential energy U will be equal to 1 upon 2C. Here put the limits just Q, so this will become Q square. So you have got U equal to Q square upon 2C. But you know Q equal to CV. If you want to write another formula, so put here CV. So what will you get? C square V square divided by 2C. So you will get half CV square. Right? In terms of charge, if you want to write, if you want to remove here capacitance, then further you can write in place of C from Q equal to CV. You can write C equal to Q upon V. So if you write Q upon V, then you will get this energy Q equal to U equal to half QV. So three formula are possible for the potential energy stored in a capacitor. Now next point is energy density. So what is energy density? Energy density is potential energy per unit of volume. Right? That is potential energy you have got CV square divided by volume is area into separation between the plates. Here, in terms of electric field, if we want to write, suppose electric field is E0. So in terms of E0 or just E, you can use, and C equal to, if you use epsilon naught A upon D. And you know, V upon D equal to E, or V equal to ED. So if you use these things, what do you get? Energy per unit volume, let's write it U small d, energy density, and half C means epsilon naught A upon D, half C into V square. Keep voltage as ED, so E square D square, 1 by 2 C into V square divided by AD. What happens? D will cancel D square, A will cancel A. So you will be left with 1 by 2 epsilon naught E square. So this is energy density, this is small u. I think this is very clear. Now, we are going to see another concept. Here, there is one numerical. Numerical says you are given a capacitor. A 900 picofarad capacitor is charged by 100 volt battery. How much electrostatic energy is stored by the capacitor? So this is first part. And recently you have studied that energy stored is given by half CV square. Capacitance is given, voltage is given. So you can easily evaluate. So this is first task. Okay. So half CV square, 1 by 2, C is 900 into 10 to the power minus 12 into voltage square, that is 100 square. So if you evaluate, you will get 4.5 into 10 to the power, how much? Minus 6 joule. So this is first part of the question. Question is simple. Now, second part of the question says the capacitor is disconnected from battery and connected to another 900 picofarad capacitor. Okay. So what is electrostatic energy stored by the system? So whenever we connect a capacitor to another capacitor, then common voltage is established. So if we find out common voltage, so what is that? So common voltage, suppose there are two capacitances, one is C1, another is C2, they are at voltage V1 and V2, then common voltage or common potential is C1 V1 plus C2 V2 divided by C1 plus C2. So here in this case, second capacitor has same value 900 picofarad. C1 C2 both are equal, but voltage for second is 0 in our question. So we can put the values. So what do we get? C1 C2 are same, so just write C and here 2C. So you will get V dash new voltage, suppose this is V dash, so CV divided by CV divided by 2C, that is V by 2. It means voltage will become half. So what about charge? You know Q proportional to V, so charge will also become half. So both things will become half. And if you remember, energy stored is given by either half CV square or half QV. So if you write half QV, so there are two capacitors, so total energy stored U, in this case two capacitors are there and half QV each. So here Q dash into V dash, and Q dash means charge is equally shared, and voltage we have found that voltage becomes a half. So 2 will cancel out. So we will write Q dash. So Q by 2 into V by 2, that is 1 by 4. So here don't write 1 by 4, just write 1 by 2 QV, so that you can compare. This is original energy and it is getting divided by 2. So in previous case it was 4.5 into 10 power minus 6 joule. This time it will become U dash, let's write. So U dash will be half of that value. So it will come out to be 2.25 into 10 power minus 6 joule. I think you understood. Now, so there is one question. If there is energy loss, so where is that energy gone? Is there any violation of energy conservation principle? No, of course no. Energy lost is converted in another form. So it can be in the form of heat or in form of electromagnetic radiation. So energy conservation still holds here. I think you have understood. Now this chapter is over. Now we are going to see some numericals based on the chapter. Okay. Let's see the questions. So numericals are: the first question, two charges 5 into 10 power minus 8 coulomb and minus 3 into 10 power minus 8 coulomb are located 16 centimeter apart. Here one is 5 into 10 to the power minus 8 coulomb, another is minus 3 into 10 power minus 8 coulomb. Okay. Separation is 16 centimeter. No problem. At what points on the line joining the two charges is the electric potential 0? So first consider case number 1. We are taking point here. Later on, second point we will consider another way that I am going to tell you. So let's write this distance as x. So this will become 16 minus x. Both are in centimeter. At this point, potential is 0. It means potential due to this must be equal and opposite to potential due to this. So either we write from formula Q upon 4 pi epsilon naught R equal to V. We can write, so 5 into 10 to the power minus 8 divided by 4 pi epsilon naught. It's not necessary to put the value because they will get cancelled, into separation x into centimeter. So 10 power minus 2 must be equal to 3 into 10 power minus 8 divided by separation 4 pi epsilon naught times separation is 16 minus x. Now try to solve it. 4 pi epsilon naught cancel out, 10 power minus 8 will cancel out, 10 power minus 2 here also, this is centimeter, so 10 power minus 2 must be there. So 10 power minus 2 will cancel out. What will be left? 5 upon x equals 3 upon 16 minus x. Try to solve it. Take 1 minute. So you will get x equal to 10 centimeter. Correct? This is case number 1. Let's take another case. It may happen that this charge is here 5 into 10 to the power minus 8, and this line joining here. Second charge is here minus 3 into 10 to the power minus 8. This is second case. And so P is that point where potential is 0. So due to this distance is suppose x, and this 16 centimeter, power minus 8 divided by 4 pi epsilon naught and the separation is x must be equal to, here in centimeter, so you have to write 10 power minus 2, and here this will become 3 into 10 to the power minus 8 divided by separation is x minus 16 into 10 to the power minus 2, and here this will become 4 pi epsilon naught. Now again you can simplify 10 power minus 8, 10 power minus 8 cancel out, 4 pi epsilon naught, 4 pi epsilon naught will cancel out, 10 power minus 2, 10 power minus 2 will cancel out. Now give few minutes, not few minutes, just 1 minute to get x. Try. So if you evaluate, you will get x equal to 40 centimeters. So there are 2 points where potential is 0. One is here in midpoint and another is in the side of negative charge. So I think you have understood. Now let's take next question. A regular hexagon of side 10 centimeter has a charge 5 microcoulomb at each of its vertices. Calculate the potential at the center of the hexagon. Question is simple. Here you are taking hexagon, like this. Everywhere there is charge Q. So let's write here Q, 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 Q. Since potential is a scalar quantity, so we can find potential at the center due to one charge and we can multiply by 6. So first of all, we have to find out what is this distance. So each angle will be 60 degree. So hexagon, so this angle will be 60 degree because 120 each, so this is also 60, so these two sides will be equal, so 6 means all three sides will become equal. So here side length is given as 10, so this will also be 10, similarly for others. So potential due to this charge at the center can be found, and total potential if we want to find out, as I told you, so 6 times any charge divided by 4 pi epsilon naught times r. Now let's put the values. So we will be equal to 6 times 9 into 10 to the power 9 times charge. Charge is 5 microcoulomb, 5 into 10 to the power minus 6 divided by separation is 10 centimeter, that is 0.1. Now take 1 minute to evaluate. So you will get 2.7 into 10 to the power how much? Will it be 6? Just check. So it will be 6 volt. Correct? Let's take next question. Next question says two charges 2 microcoulomb and minus 2 microcoulomb are placed at point A and B 6 centimeter apart. Identify the equipotential surface of the system. What is the direction of the electric field at every point on this surface? So it is simple. So here this is 2 microcoulomb this is minus 2 microcoulomb. So equipotential surface we have to find out. So this is midpoint. So you can make a equipotential surface like this. Right? So direction of electric field will be in this direction. So this will be at the midpoint, means 3 centimeter from positive charge. So identify the equipotential surface of the system. So like this, and direction of the electric field will be like this at every point toward the negative charge. So question is clear. Let's go to next question. Next question says, a spherical conductor of radius 12 centimeter has a charge of this much distributed over its surface. What is the electric field inside the sphere? If you remember, if there is a sphere and charge q is given to it, then total charge will go to the surface. So inside there is no charge. So there won't be any electric field inside. So E inside will be just 0. So there is no problem. Now just outside. So just outside means this is equal to radius 12 centimeter, and then electric field can be found by formula E equal to Q divided by 4 pi epsilon naught R square. Put the values. Q is given as 1.6 into 10 power minus 7. So 1.6 into 10 power minus 7 into 9 into 10 to the power 9 divided by R square. Separation is 12 square, so 0.12 whole square, and either volt per meter or Newton per coulomb. Just evaluate it and tell me the answer. Now, what about third part? Add a point 18 centimeter from the center of the sphere. Now this point lies here. So nothing will change. Charge will remain same. Only separation will change. So this time suppose E outside, you write it. So it will become same thing will remain there. So previously it was 0.12. This time it will become 1.6 into 10 power minus 7 into 9 into 10 to the power 9 divided by, this will become 0.18 whole square and Newton per coulomb. Valuation you can do. So I am leaving it for you. Is it okay? Okay. Now we are going to take another question. Next question says, a parallel plate capacitor with air between the plates has a capacitance of 8 picofarad. It means C equal to epsilon naught A upon D is given as 8 into 10 to the power minus 12 farad. Now, what will be the capacitance if the distance between the plates is reduced by half and space between them is filled with substance of dielectric constant? If you remember, if we put dielectric constant, then C dash becomes epsilon naught A upon D times K. But here two things is happening together. Two things are happening together. One is something is filled, another D is here separation between plates is made half. So here just divide by 2. So simplify. 2K epsilon naught A divided by D. But epsilon naught A divided by D is given 8 into 10 power minus 12. So 2 into K. In our question, value of K is given as 6. So put here 6 times 8 into 10 to the power minus 12 and farad, evaluate it, and if you want to keep this 10 power minus 2, then write. If you want to remove this, then picofarad. Otherwise, the way you like, even you can write in terms of negative power. You can write in terms of nanofarad, etc., etc. That depends on you. Now, let's see next question. Next question is 3 capacitors, each of capacitance 9 picofarad, are connected in series. Okay, what is total capacitance? So you know very well, if capacitances are connected in series, so this is suppose one capacitor, another here, another here. So C1, C2, C3. So equivalent, you write CS equal to 1 upon C1, C2 plus 1 upon C3. There is no doubt. So here question says 3 capacitances of these values are connected in parallel. I think we are doing this question. Sorry, 3 capacitors, each of capacitors, these are connected in series. What is the total capacitance of the combination? So you can write 1 upon 9 plus 1 upon 9 plus 1 upon 9. That is 3 upon 9, 1 upon CS. So this gives CS equal to 3, and whatever unit is there, it's picofarad, so answer will be picofarads. Up to here, there is no doubt. What is the potential difference across each capacitors of the combination if connected to 120 volt supply? So it is simple, because they are in series, so voltage will be equally divided as the values of capacitance are same, no? So here what you do, just divide voltage V by 3, V by 3, V by 3. So whatever value is given here, 120 volt is given, so you can write 40, 40, 40. So in this question, nothing was difficult as such. Let's see next question. Next question says 3 capacitors of capacitance 2, 3, 4 picofarad are connected in parallel. What is total capacitance? So again, it is simple question. You know, C parallel is given by C1 plus C2 plus C3. You can put the values. C1 is 2 plus 3 plus 4 picofarad, means 10 power minus 12. Simplify. 9 into 10 to the power minus 12 farad. There is no doubt. Now determine the charge on each capacitor if combination is connected to 100 volt supply. These are connected in parallel. So it is simple. So charge Q1, Q2, Q3. So for each voltage is same. So Q1 equal to C1V, Q2 equal to C2V, and Q3 equal to C3V. Voltage is given and capacitances are also given. Just multiply by voltage to get the value. I'm not doing because it is so simple. Then now we are going to see one more question, but just read the question. I'm coming. Sorry. Yeah. So next question is, in a parallel plate capacitor, with air between the plates. Each plate has an area of 6 into 10 power minus 3 meter square and distance between the plate is 3 mm. Calculate the capacitance of the capacitor if capacitor is connected to 100 volt supply, and what is the charge on each plate of the capacitor. Think. You can do. It's not tough. Information is given. So area is given as 6 into 10 to the power minus 3 meter square, and the separation is given as D equal to 3 into 10 to the power minus 3 meter. You have to find out the capacitance. So this is parallel plate capacitors. You know capacity of parallel plate capacitor is given by epsilon naught A divided by D. So you can put the values. So epsilon naught is 8.85 into 10 to the power minus 12 multiplied by area. Area is given as 6 into 10 to the power minus 3 divided by D separation 3 into 10 to the power minus 3. Now evaluate it. You can easily evaluate. You can cancel these 3 2s etc. and then write. Then what is next part? Next part says what is the charge on each plate. So charge Q equal to CV. C you have found from here. Put that value, and voltage is given as 100. Multiply by 100. You will get the answer. Now we are going to take other questions. So explain what would happen if the capacitor given in exercise 2.8, a 3 mm mica sheet of dielectric 6 were inserted between the plates, while the voltage supply remains connected after the supply was disconnected. So two situations are there. So if you remember, capacitance C is epsilon naught A. Sorry. C equal to epsilon naught A divided by D. If space between the parallel plates is filled by some dielectric constant, so C dash will become epsilon naught A upon D times K. Right. So here dielectric constant is given 6. So in previous answer, in previous question, whatever answer you have got, you can multiply it by 6 to get the result. While voltage here, voltage supply remains connected. So nothing will change, charge will remain same. And second case is when supply is disconnected. Now, when supply is disconnected, what will happen? Everything will remain same. Capacitance will increase. So C dash will become normal as in case of supply remains connected. Charge will also remain same. There won't be difference. But what will happen to the voltage? Voltage will change by by what? Voltage will become V upon K, where K is dielectric constant. I think you have understood. Now let's see next question. Next question is, a 12 picofarad capacitor is connected to 50 volt battery. How much electrostatic energy is stored in the capacitor? So if you remember, electrostatic energy U is given by half CV square. 1 by 2, capacitance is given 12 picofarad. So 12 into 10 to the power minus 12 into voltage square, so 50 square. You can evaluate and that will be in joule. Now, last question. It says 600 picofarad capacitor is charged by a 200 volt supply. It is then disconnected from the supply and is connected to another uncharged 600 picofarad capacitor. How much electrostatic energy is lost in the process? So before solving this question, I am going to tell you one concept. Then it will become easier, and sometimes that concept is also asked. So it will be better for you to know about it. So you are given, suppose, capacitors. So C1 and C2. Voltage say V1 and V2. Then common voltage will be C1 V1 plus C2 V2 divided by C1 plus C2. Initial kinetic energy U initial will be half C1 V1 square plus half C2 V2 square. Final kinetic energy U final will be half and C1 plus C2 times V square, but V is this much. So 1 by 2 C1 plus C2 times V means C1 V1 plus C2 V2 divided by C1 plus C2 whole square. So this is final energy. This is initial energy. Now energy lost, if you want to evaluate, so what you do? Just write Ui minus Uf and put these values like half C1 V1 square plus half C2 V2 square minus, here if you observe C1 plus C2 whole square, so this will get cancelled. So you will get 1 by 2, then C1 V1 plus C2 V2 whole square divided by C1 plus C2. So this is basic expression where both capacitance have certain voltage. Now in our situation, what is happening? Here 600 picofarad capacitor charged by 200 volt supply. So C1 is given as 600 picofarad and V1 is given as 200 volt. C2 is given to another uncharged, same value. C2 is given as 600 picofarad and voltage V2 is 0 because it is uncharged. So V2 equal to 0. So here in this equation you can put values. So this term will become 0, alright, and here also this term will become 0. So C1 square V1 square divided by C1 plus C2. So let's simplify it to get the answer. So we can do either this directly, or if we want to go step by step, that is also possible. So I am going to tell you second method also, because I have explained you can just put values to get the answer. if we follow second method, so in second method, what is common voltage? Or first you find energy initial UI, so half C1 V1 square, because V2 is 0, so C1 half C1 is 600 into 10 to the power minus 12 into V1 square, voltage is 200 square. So this is initial potential energy. We can simplify with this, but I'm just leaving it for you. And now we need U final. So as I told you, 1 by 2, sum of the two capacitances C1 plus C2 into common voltage V square, and V will be equal to C1 V1 plus C2 V2 divided by C1 plus C2. Here V1 is given, C1 is given, but V2 is 0. So C1 is 600 into 10 to the power minus 12 into V1 is 200 divided by C1 plus C2, 600 plus 600 into 10 to the power minus 12. So what is happening? So it will come out to be 100 volt. Right? So you can put these values here. So U final will be 1 by 2 C1 plus C2, so 1200 picofarad into 10 to the power minus 12 into V square. What is voltage? Say 100 square. Now the final work left for you is to find the difference. So UI minus UF, how much will you get? Can you work out? You can work out, that is your work, and I think you can get the answer. Now what is next part? Here there is another part, how much electrostatic energy is lost in the process, so that you will get. And if sometimes it is asked that where has this energy gone, so answer is very simple, as we have seen that whenever two capacitors are connected, then due to heat, when current flows, then there must be loss of heat, and also certain EM waves will also cause this loss of energy. So electromagnetic radiations, so you can say energy is lost in form of heat and electromagnetic radiations. So I think you have understood fully the chapter, and you must have enjoyed. Thank you, Team Educate.